Hello everyone, myself Pinaki Mishra and I'm back with another video of VPN, which is the Network Security 101 series. Let's deep dive. What is a virtual private network? Copyright notice. They have copyright, so the all whatever I'm teaching goes to the Politecnico di Torino and the Duan facility. A definition, virtual private network. All credit goes to those. Politecnico di Torino. Connectivity realized on shared infrastructure such that policies can be enforced as in private network. Shared infrastructure, private public network, one of those internet service provider, IP frame relay, ATM, the internet policy, security, quality of service, QoS, reliability, addressing, etc. Let's see what it is. Hmm. Okay. Method creating a secure connection over a public shared infrastructure like the internet. Here's the breakdown. Shared infrastructure. The VPN uses the existing networks, usually the internet. Instead of requiring a dedicated private line, connectivity realized. Despite being public infrastructure, the connection behaves if it were private. Policies enforced as in private network. Security rules, access controls, and other administrative policies can still be applied as if users were connected to a company-owned private internal network. So, in essence, a VPN allows users to connect a network with the same security and control you expect from a private setup, and even though the underlying network is public. Want to go deeper and how it works and when do you use one? So this is the sample use case, traditional private network. This is the traditional private network. There is a firewall and it is connected to my server and computer, and there are three more systems. This is VPN. So VPN is already established there on the internet, then it goes to firewall, then it goes to VPN, then it goes to the main server. So what are the key element tunnels? Secure encapsulation, corporate traffic while in transit, not present in some solutions. So let's ask this one too. Snippet. Clients virtual components of virtual private network, the tunnel-based context slide tech you are looking at. Here's how it breaks down. Tunnel refers to the logical path which data travels securely between two endpoints, even though it traverses a shared, often public network like the internet. It is a way of making public pathways behave like private corridors. Secure encapsulation means that the corporate traffic is wrapped or encapsulated in a protective format that keeps its content hidden and tamper resistant. While moving across the shared infrastructure, this often includes encryption, ensuring confidentiality and integrity not present in some solutions, remind us that while tunneling is hallmark of many VPNs, some implementations may not use it or may use less secure variants. For instance, simpler remote access solutions or certain cloud-based models might handle the traffic differently, trading off some security or control to ease of deployment. And what is VPN gateway? Let's ask this too. Teach me about text in layman terms, more like anime style. This is pretty much fun. After this, let's turn this VPN concept into a scene state of your favorite cyber adventure saga. So, in the vast digital realm, there might be fortress, the corporate network. It's protected by a powerful guardian known as the VPN gateway. Powerful guardian known as VPN gateway. Think of it as the stoic gatekeeper standing tall at the edge of the fortress walls. The world outside, its chaotic land, the internet data from remote heroes, aka employees working from anywhere, must pass the safety through this world to reach the fortress. But in danger lurks everywhere: spies, hackers, and packet monsters. Enter the VPN tunnel, high-speed dimensional portal conjured by magic. Okay, Encryption that wraps the hero message in a invisible cloak. But every tunnel needs a destination, and that's where VPN Gateway shines. Key powers of VPN Gateway is the arrival point of these secure tunnels, like sacred gates, where only those with the right symbols can enter. It may also be one end of the tunnel itself. Imagine it both receives and summons the protected path from afar. It checks credentials, deciphers secrets, and ensures only worthy messages, aka legit corporate data, get through the walls. In short, the VPN gateway is like the enemy guardian at the gate, serious, trusted, and always watching. Motivation: why VPN? Okay, VPN enabling cost cut solutions. VPN enable cutting costs with respect to expensive connectivity solutions. Private networks are based on private lease lines, long distance dial-up solutions. An example: T1 connections between San Francisco and New York City, $10,000 per month. Access and dial from Denver, Chicago to San Francisco, $600 per month. Total 3 year savings, 200 $237,600. VPN equipment purchase $7,800. So that's much it costs. Why VPN? VPN enables selective and flexible access to corporate networks services. Limited services available to external users. High security. Few services allowed through firewall. All internet functionalities available to corporate users accessing from the intranet. VPN connection allowed through firewall services available as if connected directly to the corporate network. This is the example. Let's explain this example in anime style. Explain me this example in anime style. And in layman terms. Basic terminology and scenarios. Many VPN solutions describe different key features. The Cyber Sentinel, the guardian of data realm, scene setting far across the swirling chaos of the digital world lies a mighty stronghold, headquarters LAN, or as the heroes call it, Cyber Castle Alpha, guarded by the enchanted firewalls, picture flame wielding dragons, and watched over by vigilant VPN gateways. This is the heart of organization's secret archive. But danger brews in the open weeds of the internet realm, teeming with rogue packets, shadowy hackers, and wild traffic storms. Meet the heroes, the road warrior, a solo digital samurai connected to headquarters from cafes and mountains cabins alike. She sends encrypted scrolls through a glowing portal called a VPN tunnel, hoping they reach the castle safely. The telecommuter, a wise taxi working from a tranquil outpost, aka home office, whispering through a secure channels to the guardians of headquarters, remote LAN, distant digital villages, each guarded by its own router Ronin and firewall sentinels, wishing to link up with the Cyber Castle Alpha for a peaceful alliance and the share quest, aka file sharing and secure communication. The tech magic in play. VPN gateway is the mystical portal master. At the castle gates, it can open or seal the VPN tunnel, decipher secret codes, and verify if incoming travelers are friend or foe. The tunnel itself, a shimmering wormhole made of cryptographic light It cloaks all messages so they travel unseen, unheard, and untouched. And through the stormy internet realm, a firewall, a fire-breathing guardian who only lets through those carrying VPN gateway seals of trust. The plot twist. Even though our whole heroes scattered across the lands, aka different networks. They act as though they are right there in the castle halls, sipping cold tea together, thanks to the power of VPN. Many VPN solutions try to identify key features, so, three-dimensional deployment model, overlay, and peer. So from the peer, it is the customer, provider, and provisioning model. Overlay count to the here and protocol they will count to the here and categorize the VPN solutions. So the VPN have two type of solution: overlay model, peer model. Overlay model works on three layers, which are layer 2, layer 3, layer 4. On layer 2 they use frame relay, ATM, MPLS. So these are the protocol that they use. On the layer 3 VPN they use IPsec GRE, and the other one is L2TP and PPTP. Layer 4 is SSL. So what comes in the peer model? Dedicated router, MPLS, and MPLS also come here. So dedicated router, MPLS, shared router, BGP and VR. Customer provision, provider provision. These two are identified. Sorry. And categorize the many VPN solutions. So let's go. We have different kind of VPN flavors. Access VPN or remote VPN, virtual DIN connects terminal to remote network. Virtualizes dial-up access connection. Site-to-site VPN connect remote network. Virtualizes lease line. End-to-end VPN connect remote host. Virtualizes lease line. Everything is virtualizing the lease line. Site-to-site and end-to-end both. Connect remote host, connect remote networks. So difference between host and networks and site and end-to-end. At access VPN or remote VPN or virtual dialing. Connect terminal or remote to remote network. Virtualized dial-up access connection. VPN deployment scenarios. Intranet VPN. Interconnection of corporate headquarters, remote offices, branch office, telecommunicator, traveling employee. Extranet VPN. Interconnection of customers, suppliers, partners, or communities of interest to a corporate intranet. Provide control access to an individual customer, partner, provider, user. What is intranet and extranet VPN? Explain me in simple layman terms. Explain me intranet VPN and extranet VPN in layman terms with real life example. Simple internet architecture, corporate servers, email, file, www. Internet, corporate servers are connected to the internet and then it is connected to the remote side. Also, internet is connected to the sales, finance, and IT department. So, what is the internet VPN? The digital office highway. What is it? What it is? The VPN connects different parts of the same company. Imagine your company headquarters in Milan, a branch office in Naples, and some employees working from home in Rome. An internet VPN securely links them all together as if they are in one big building with hallways connecting in every room. Real life example, your sales representative working from a beachside cafe in Bari, lucky you. You use the company internet VPN to log into the corporate email and download sensitive reports, even though you are just using public Wi-Fi. It's as if you are sitting in a Milan head office behind all the security walls. pretty much easy. Okay, so let's go to the sample of extranet architecture. We will study this too. Sample external architecture, extranet architecture, sorry. We have this extranet, so it goes to the firewall, then it goes to supplier, then it goes to firewall, it goes to customers, then it goes to firewall, then it goes to corporate servers, then it goes to firewall, and then again it goes to firewall to the sales, then firewall to the finance, then firewall to the IT. So what is it? This VPN links your company to the organization of people like suppliers, customers, trusted partners without giving them full access to your entire network. You give them just enough access to collaborate securely. Real life example, your company makes designer shoes, you are partnered with the leather supplier in Spain and shipping company in Germany. You don't want them poking around your HR files, but you need them to view inventory and shipping schedules. So you set up extranet VPN that gives them access to only that part of your network, like handling them keys to just one of the room, not the whole mansion. If the internet VPN is your private subway system, the extranet VPN is more like inviting guests into your backyard through a side gate with a security guard watching. Want me to? Oh. Extranet specific issues, restricted access to network resources from interconnected networks, firewall at the VPN, or overlapping addresses spaces. Network address translation, open standard based solution enables interoperability among different organizations. And traffic control, avoid that partner traffic compromises performance on corporate network. So it has some specific issues. Extranet, internet access, centralized. Remote branches users use public IP not only to reach headquarters. Internet access only from headquarters. VPN carries also traffic to and from the internet. Centralized access control, firewall. Distributed. Remote branches uses access the internet through the IP network connection. VPN is deployed only for corporate traffic. Distributed internet access. So we have this headquarters and router A, and then we have ISP backbone, which is internet service provider. Then we go to the internet, and we have the router B, which is the remote branch, and they both goes to the internet using the firewall and the router. Distributed internet access. Centralized internet access, router A, the headquarters goes, then it goes to the backbone. There are two more routers, B and C, router B and router C, and they both are at the remote branch. Someone is working from the remote side as a cybersecurity engineer, then they go to there, and then the ISP, we let the ISP, and then ISP go to here. So first, the centralized internet access is this. The ISP let the user directly go to the headquarters first. Then it let you to the internet. That's how the centralized internet access works. Deployment model and main concepts. VPN features separate data tunneling, increase protection, encryption, prevent tampering, integrity, identify source, authentication, basic security objectives, endpoint. Example, source destination authentication. Ensure it is what who it declares to be. Basic security objective. Endpoint, source destination, where the data is coming for. Ensure who is coming. Data integrity. Ensure the data is not changed, including coming from the declared source. Even the source is declared where it is coming from, the data should not get changed while coming to us. Data confidentiality. Data cannot be accessed read by anyone else other than the intended destination. The data should not be read by anyone else other than intended destinations. S2S VPN tunneling, tunnel terminated on gateway. So corporate side 1, tunnel endpoint X, public network internet, tunnel endpoint Y, and there we have corporate side 2. So corporate side 1 and corporate side 2, they both are connected with the tunnel endpoint. There is tunnel point endpoint X and tunnel endpoint Y at the both the corporate sites, and here we have this tunnel, which is the public network internet. Tunnel terminated gateway. E to E, this is the S to S VPN tunneling. Think it is site to site VPN tunneling. Then this is the end-to-end VPN tunneling. Tunneling terminate to end systems. Corporate network A and the corporate network B. They both are connected with the tunnel, but they are not having the endpoint here. They are directly connected to each other and to the network. Remote VPN tunneling. Tunnel terminated on end systems and VPN gateway. Corporate network tunnel endpoint X. Internet, and then it is connected to the tunnel. Corporate network, which is B. So this is remote VPN tunneling. So a user is having the remote VPN and it is tunneled through the internet and then go through the corporate network, which is tunnel endpoint X. Then it gets into the corporate network. So overlay model, the public network does not participate in realizing the VPN. It does not know where the VPN destinations are, just connectivity among VPN gateways. Each VPN gateway must be in touch with every other VPN gateway. Example, highly meshed tunnels. Routing is performed by the VPN gateways. Peer model, each VPN gateway interacts with public router, its peer. Exchange of routing information, service provider, network disseminations, routing information. Public network routes traffic between gateways of the same VPN. So let's first get the example for this one, overlay model, real life example. Mm, Life example for this overlay model in layman terms. Imagine a secret underground messenger club. Say five secret agent VPN gateways are stationed across the world: Rome, Tokyo, Cairo, New York, and Sydney. They want to send classified messages to each other, but they can't trust the regular postal system, public internet, to do that directly. So they each build their own private tunnels underground. These are encrypted VPN tunnels, but here's the thing. The postal system still exists above the ground. It's the public network, but it has no idea their secret tunnels exist. No one in the postal system knows where these agents are and who they are talking to. These agents must coordinate directly with each other to build these tunnels, like exchanging coordinates in advance. Every agent has to maintain a connection to every other agent. They are all in touch, forming a spider web of underground paths. This is a mesh. Every agent has to maintain connection to every other agent. They are all in touch, forming the spider web of underground paths. This is a mesh. Okay. In tech terms, in the public internet just moves the encrypted data blindly. It doesn't help with the routing or discovery. All the smartness, like the who to talk and how, lives in the VPN gateway. So you as the organization maintain control, but also must handle all the setup. Real world case scenario: a multinational bank wants full control over its internet branch communications. Each bank has a VPN gateway. Instead of relying on ISP fancy routing services, they configure their gateways to connect directly with each other using encrypted tunnels. It's a lot of work, more configuration, but the bank doesn't want external providers involved in the securing routing, just like the agents and their internals. Want to turn this into blah blah blah, and let's go into the peer model. Explain me this too. Explain me this too in the like previously, like previous method. You got it, Pinagi. Let's summon another real life anime style metaphor for the peer model. Peer model, the allied portal network. Imagine we are in the cyber fantasy world. Each VPN gateway is a magical outpost like floating fortresses in the sky, but unlike the overlay realm where they build their own hidden tunnels, in the peer model world, the gateways form alliances and nearby public routers think local teleportation towers. Real life analogy, public travel. Let's say each VPN gateway is like a city Milan, Berlin, Tokyo, and each one has a rail station, the public router. It's connected to every city, sends routing info to its station. The public rail network, the internet shares this info with all the other stations. So if City A wants to send a cargo to City B, the public railway system knows the entire routine, even though the cargo is encrypted and protected. The cool part, the VPN gateway don't have to build or maintain every single tunnel themselves. They trust network to do the heavy lifting based on the routes it knows from the initial handshake. Key features, easy terms. Key features in easy terms. Each gateway talks to its buddy router. On the public network, it's like giving a cheat sheet of addresses. Public network figures out the best route to send the secure cargo between VPN location. The routing information flows through the service provider network, which becomes a smart assistant instead of just a dumb tunnel. Real world example, let's say your company has offices in Rome, Paris, and Madrid. Each office VPN gateway connects to the local ISP router rather than having each site build direct secure links to every other overlay model. The ISP network handles it. Gateway says, here is my address. ISP says, got it. I will guide you messages to the right gateway. Now, Rome office can talk securely to the Madrid and ISP routers will get it there safely and efficiently. Customer provisioned VPN. Customer implements VPN solution, owns configuration, manages device, implementing VPN functionalities, customer equipment. Network provider is not aware that the traffic generated by the customer is VPN. All VPN features implemented in the customer devices. Customer experience terminates tunnels. I think it is something else, but customer provisioned VPN. So this is the customer. Okay, what is the CE means? Customer equipment, I see. So CE means customer equipment, terminates tunnels. So, and what is PE? Provider equipment. Okay, so this is the provider equipment. They created a web. And then there is customer equipment. They have connected their everything with the provider equipment, and provider equipment is connected to each other. So site 1, 2, 3, these three are connected to each other, and site 4 and 5 are connected to each other. This is the virtual link which is connecting to them. Provider provisioned VPN. Provider implements VPN solution, own configuration, manages devices, implementing VPN functionalities. VPN state maintained by the provider devices. Traffic belonging to VPN, different VPN is separated by the provider devices. Customer equipment may behave as if it were connected to the private network. Private equipment terminates VPN tunnels. So this is the provisioned VPN. So everything is given by provider, so they do not have to do much, I think. This is the provision VPN. So these are already connected to each other, and customers customer equipment is connected to every site also. They are connected with site 2, site 4, and site 3. And site 1 and site 5 are virtually connected. So what is the access VPN customer provisioned? Okay, access VPN customer provision. We have this corporate network. We have this system here. This is the corporate network, corporate security server. This is corporate security server. This is corporate network. This is the system of corporate network. So this is public internet. Corporate security server is sending, is getting out from here to the tunnel, and then it goes to some kind of IP, and then it goes VPN gateway assigns corporate addresses. So this is assigning the corporate addresses. Tunnel endpoints are these, connection endpoints are these. Access VPN, customer provision. Let's get this real world example for this one. Give me a real world example for this. Easy to understand. The remote worker tale. What makes a customer provision? Her company gives her a special VPN client app for her laptop. The laptop creates secure tunnel from the Florence to Milan every time she logs in. All VPN functionality, encryption, authentication, tunneling is handled by her device, not by her internet provider. Her company doesn't ask the internet provider to set anything else. It just needs the VPN tunnel to work securely over any internet connection. Sarah might use home Wi-Fi, cafe, hotspot, and even her phone's mobile data. So it's Access VPN because it connects a single device, Sarah's laptop, into a corporate network. And it's customer provision because the customer Sarah company handles everything software configuration keys, not the ISP. Customer provisioned versus provider provisioned. Customer provisioned versus provider provisioned. Provisioned, yeah. Customer provision has remote host to addresses ISP assigned and corporate. Remote host terminates VPN tunnel. Remote host must activate tunnel. If tunnel is not activated, the client can operate without VPN. Can be used from any internet connection. These are the benefits. What are the provider provision? Remote has host has first address corporate. NAS terminates VPN tunnel. Network operating security layer. I think remote host is always on VPN. Internet access to only centralized people and requires access to specific IP address. Tunneling: a packet or frame between private sites is carried through a public network within a packet handled by public nodes. So we came to the tunneling part. So a packet or frame, let's get this thing in easy language to understand. Mm, check the attached image. For tunneling, tunneling. You want to send a private letter from your home to corporate site 1 to a friend in a corporate site 2, but the world's postal system aka public network like the internet isn't very secure. Anyone could peek at your messages on the way. So what do? You place your private letter, the payload, into an inner envelope. Then you place the entire inner envelope into a bigger outer envelope. Envelope into envelope. On this outer envelope, you write send from tunnel endpoint X to tunnel endpoint Y. The postal workers, public network routers only look the outer addresses. They don't know or care what is inside. When the envelope reaches the tunnel endpoint Y, it opens the outer envelope and reveals the original private letter inside the ready to be delivered to your friend. In networking terms, the inner letter is your corporate data payload. The outer envelopes is your new packet header that helps it travel across the public road safety. Tunnel endpoint to X and Y are the gateways and that unwrap the message. They trap and unwrap the message. The public internet handles the delivery but never sees what's inside. Real life example, you are working on remotely from a hotel, you log into your company VPN. When you access the company files, your request is wrapped in encryption and an outer packet. The request travels across through hotel Wi-Fi, public network, and the internet. It arrives securely at the company's VPN gateway, which unwraps the packet and sends your real request to the company servers. So even though you are sending stuff through your public routes, no one can peek inside your company. Uses the private tunnels across the internet highway. So this is the internet highway, I think. Corporate side 1, tunnel endpoint X, then public network. This is the tunnel endpoint Y. This is the corporate side 2, header from X to Y, header and payload. Header is getting used from X to Y, and then there is a payload. Virtual VPN topologies, hub and spoke. Each branch communicates directly with headquarters, fits to data flow of many corporations, mainframe or data centers. Routing is suboptimal, small number of tunnels. Hub could become bottleneck, mesh, larger number of tunnels, harder to manually configure, optimized routing. Okay, so this is the layer 2 VPN, virtual private LAN service. Well, let's have it that way. Um, Layer 1, 2, 3, 4. Okay, so let's have this convo to the AI with the real life examples. Let's learn in real life example. Give me IP tunneling layer 4. Explain me every layer of this VPNs and give me the real life example for every layer VPN. I hope in layman terms or anime style possible. Give me more, give me more. Let's take a tour through each VPN layer and topology, anime style with real world examples that make them easy to picture. Virtual VPN topologies, hub spoken the command castle. Think of this as a massive kingdom. Let's get to that thing first where I have selected. Think this is a massive kingdom. The headquarters is the grand castle hub, and each branch office is a village spoke connected only to the castle, not to each other. Villagers can only pass letters through the castle. If a villager wants a message village B, it first goes to the castle, then castle sends to the castle B. Downside, if the castle gets too many messages, it becomes a bottleneck. A real life example, a certain chain with a head office in Milan and branches across Italy. Each store connects only to Milan, not to each other. Okay. What is layer 2? Mesh? No, first mesh. Here's every branch can talk directly to every network. No castles needed. It's like a network of ninja villages with magic tunnels to each other. Messages take the fastest route. No center relay. Awesome for speed but hard to manage. So many tunnels. Real life example, a multinational team of engineers in different cities who collaborate in a real time. Each office connects directly to all other. VPN layers explained. Layer 2, LAN illusion spell. These VPNs make distant network behave like they are all plugged into the same Ethernet cable. Virtual private LAN services. The big invisible LAN. It acts like a giant office LAN where even if the users are in different cities, uses MAC address to forward data. Examples: you are in the Florence office working on a shared spreadsheet with someone in Naples. It feels like you are on the same floor thanks to VPLS. Okay. Virtual private emulates functionalities of LAN, can view LAN segments, solution makes bridges, learning emulates makes learning bridges, route-based MAC address, virtual private wire service. Okay, virtual private wire service. Emulates a leased LAN, any protocol can be carried. It stimulates a private wire between two sides, carries any protocol like blank scroll, ready to for any spell. Example, a legacy banking system needing to send non-IP protocols between branches. IP only LAN like service. So these are the okay, what was that? I think customer, customer equipment. Okay, that was the customer equipment. Good with these things. Let's see. Customer equipments are IP routers or IP hosts, not Ethernet switches. Only IP plus ICMP and ARP packets travel through VPN. Only carries IP-based traffic, no old school protocols, connect sites with IP routers or host, not Ethernet switch. Example, a company using only IP applications like web services connects sites with simplicity and speed. Okay, what is the layer 3 VPN? The smart routing plan. Layer 3 packets forwarded through the public network routing based on layer 3 addresses. Peer VPN corporate customer address, overlay backbone address, and customer equipments are each IP routers or IP host. Works with layer 3 IP addresses. VPN are built using routing tables to decide how to forward traffic tunnel types in IP, GRE, IPsec. Real life analogy: sending a letter inside an envelope. IP packet placed inside another envelope. Outer packet. Only the inner envelope matters to the recipient. Example, you log into from the Tokyo to your Milan's office server over the internet and the server sees as if you are right there. Tunneling in layer 3 VPN. Okay, so a packet frame is carried through an IP packet. Yeah, it's the same thing. And IP within IP in IP, GRE IPsec, layer 2 frame within an IP packet, layer 2 layer 2 packet, layer 2 packet, PPTP based on GRE. IPsec, what is this? Why it is not teaching me this thing? Copy. Tell me these two. What is this inside? What is this in layman terms? Give me more. Tunneling basics recap both types of gift wrapping services that have used sensitive message safer broadly stands for point-to-point tunneling protocol. Okay, point-to-point tunneling protocol invented by Microsoft. Okay, encryption, it's easy. L to TP. Layer to tunneling protocol. Okay, how it works: forms a tunnel, uses IPsec for encryption or stronger. Okay, I get that. I get that. VPN layers. I have done this IP in IP tunneling, and we are corporate network organization. Public tunneling enables communication. Smart routing. Smart routing is game or not? No, not yet. IP in IP corporate tunneling enables communication. Tunneling by itself does not ensure security. Corporate network VPN gateway X, VPN gateway Y, and its tunnel, and it is connected. IP headers from X to Y, header A to B. This is the payload. And layer 4 came to layer 4. Okay, sending VPN built using TCP connections. Tunnelized is realized by TCP connections. Security achieved with SSL TLS. Corporate network VPN gateway X and VPN gateway Y. Tunnel internet, and it's the same thing, I think. But we have this site-to-site connection. So corporate network, we have this site, and then we have the another site. So these two are established, and then we are doing this encapsulating. So uses TCP with SSL TLS to build secure tunnels. Can be site to site, end to end. Site to site VPN, two VPN gateways like Castle Gates talk to using a secure connection SSL TLS. Example, your Florence and Rome offices exchange encrypted business docs. VPN for tunneling is E to E. E to E is end to end. Possibly tunnel possibly terminated on end system, corporate network, internet, corporate network, and we have this tunnel, IP header from A to B, TCP, SSL, payload. The device themselves handle tunneling, no gateway need. We don't need a gateway here. Great for when laptops and phones securely message each other over the internet. So this is mobile to laptop, it is more easy to communicate. And categorize the many VPN solutions. Yeah, for you and your teammate log in from two cafes opposite sides of the world and collaborate security if possible. Okay, generic routing, encapsulation. We are coming to the next topic as well. Categorize many VPN solutions. We have overlay model, peer model, layer 2, layer 3, layer 4. We have studied these things right now. IPsec, GRE, PPTP, L2P, L2TP, SSL. These three we have covered. We have almost covered MPLS, peer model, customer provision, provider provision. Now we come to the GRE, generic routing encapsulation, packet information encapsulation, tunneling of any protocol, including IP to IP, header version 0, MAC header, IP header, GRE header, data, checksum. So protocol family, this is what the IP packet looks like if you ever inspected the IP packet using Wireshark. This is what it looks like. Reserved SNA OSI layer, which OSI layer it is working on. Flags version checksum optional, offset optional, protocol which protocol it is using, key optional, sequencing number optional, routing optional, packet information, generic header fields CRKS. These are the header files. Let's learn this GRE packet information. Let's have this as this one and paste it here. Explain means this diagram in layman terms, easy to understand with real life example, easy to remember. Presence absence of the optional field as a strict source routing flag. The destination is not reached when the source route list and the packet is dropped. Recur maximum number of additional encapsulation permission must be 0. Protocol ID of the protocol, payload protocol. ID of the payload protocol, routing sequence of the router IP addresses or AS for the source routing. Let's say enhanced GRE version 1. Think of a GRE like a secret mission mailbox. Imagine you are sending a secret message across a chaotic postal system in public internet and want to reach your friend from other side without anyone opening it. Here's how GRE works in this situation. Your message data, this is the actual info you want to send, maybe top secret cookie recipe in an envelope Original IP header. This shows where the message came from and where it is supposed to go out inside your company. Example from chef A to chef B. GRE header tunnel tag. This adds extra instruction like treat as secret, send in order, or this session belongs to kitchen Z. Outer envelope, new IP header. This says deliver to this whole thing to tunnel endpoint via public roads. Now postman, aka routers on the internet, only look at the router envelope. They don't even know what's inside, and it's treated as one mysterious package. Real world analogy. You are in Rome and your company headquarters in Milan. You are sending internal payroll data, but the internet is like a public delivery truck. Anyone could tamper with your documents if they weren't protected. So what does GRE do? It wraps your inner company data inside a secure tunnel envelope. It adds GRE header that includes optional info like tracking number, sequence number, a session ID key, or even list of stop if restricts delivery ordered in need. The outer envelope gets sent across the internet to the VPN gateway in Milan, where when it arrives, the outer wrapping and the GRE header are removed and the original data is delivered just like you'd handle it over in person. Why GRE? It lets you carry any kind of cargo inside, not just IP, like old school protocols too. It adds tracking info, session IDs, and optional delivery rules. It's used by VPN like PPTP and L2TP to build secure tunnels over public networks. One liner to remember: GRE is your digital FedEx envelope carrying anything anywhere safely inside a label tagged pouch. Want me to turn this into a stealth courier anime storyline next? Like GRE Guardians of Routed Encryption. So GRE means is different generic routing encapsulation. Deployed by PPTP. PPTP, okay. Acknowledgement number. Delivery of packet by remote point-to-point is notified using ACK flag A, payload length, key, call ID, protocol type, sequence number optional, acknowledgement number optional. Advanced functionalities, key high, 16-bit payload, length of number of bytes excluding GRE header, key low, 16-bit calls ID, session ID for this packet, sequence number for order delivery, error detection and correction. Sequence number is for order delivery, error detection and correction. Acknowledgement number, highest number of GRE packets received in sequence for this section. Cumulative ACK. Other mechanism in GRE. Flow control, out of order packets, timeout values, congestion control. Two protocols to access VPN. Okay, let's first learn these mechanisms with real life examples. Congestion control. Sliding window mechanism discards PPP, allows lost packet but cannot handle out of order packets. Timeout values recompleted each time an ACK packet is received. Congestion control timeouts do not cause retransmission, used only to moving sliding window. Packets will be lost, their value should be rapidly increased. Hmm. Teach me this with real life examples. Uh, not team teach key high plus low 16 bit and call ID. Okay, advanced GRE functions into super clear everyday like scenarios so you will never forget them. Ready? Think of GRE like a series of secure delivery trucks sending secret parcels across a chaotic highway. Think of this as your delivery truck secret signature mentions and mission ID. Real life example in imagine each truck packet has code book ID key and a unique mission number ID call ID. So the receiving warehouse knows where the what the session or customer it belongs to. Like this one's part of operation cookie jar or client hashtag 786 payload length. This is just the size of actual package, not the wrapping GRE header. Real life example. When scanning parcels at the post office, they don't measure the box tape, just the actual item inside, sequence number. Ensure deliveries arrive in order, no parcel is missing. Real life example, you are receiving a third part manga volume by mail. If part 2 is missing or arrives after part 3, you didn't notice the sender uses a number on each box so you can check the full set is there and the right order. Acknowledgement number ACK tells the sender I received the packet. Hashtag 12 without issues. Real life examples like confirming with the friend, hey, I got your letters up to the hashtag 12, everything good so far. Flow control, sliding window controls how many trucks packets can be on the road at once. Real life example, a delivery company only lets 5 trucks to go at once, sliding windows of 5. As soon as one delivery confirmed, a new truck can be sent. Flow control, this is the called flow control. Out of order packets discarded. Some systems like PPP can lose packets, but they freak out they arrive in the wrong order. Real life example like baking a cake and getting step 5 before step 2 useless. If the instructions are jumbled, you throw them away rather than risk the kitchen disaster. This is right out of order packets. Timeout values dynamically updated. If a delivery confirmation takes too long, update your expectations. Real life example, if your friend usually replies 5 minutes but today takes 10, you adjust your patience window. GRE does the same, recomputing how long to wait for acknowledgement. Congestion control, no automatic resend. So no oops, try again, it just moves on. Real life example, if one delivery fails, the system doesn't automatically resends it. Instead, it just notes the delay and sends to the next one faster. Memory tips feature GRE as a stealth postal ninja network. They send the messages with secret codes, track which ones made it, manage how many are in the transit, and speed up or back off depending on the traffic. All out, all without repeating deliveries unless told to. Okay, so now we have layer 2 frame within an IP packet, two protocols for access VPN, layer 2 tunneling protocol initially only provided provision, initially not widely implemented in terminals, independent of layer 2 protocol in host security through IPsec, strong but complicated. PPTP, point-to-point tunneling protocol, customer provisioned, originally proposed by Microsoft Apple, weak encryption and authentication, proprietary key management, layer-to-layer tunneling protocol, solution components, tunneling between public network access points and corporate network. Also, wholesale dial-up services between access provider and internet service provider. Layer 2 Layer 2 tunneling protocol access concentrator LSC access device supporting L2TP. Let's see original reference scenario, tunnels and sessions, L2TP operations. Okay, let's get this thing learned in the simplest terms. Imagine you are a remote worker trying to access your computer secure office network from home, tunneling. This is like creating a secret hallway through a crowded mall, the public internet, so you can get from the mall entrance to your company private offices without anyone seeing where you are going or what you are carrying. Your home internet public access point. You are connected from your home Wi-Fi. It is public because it's part of regular internet, not a part of your company or private network. Tunneling is a secret private. This is the secret hallway through a crowded mall. Internet, but get a main entrance from a company office without anyone seeing where you are going or what you are carrying. Wholesale dial-up services (ISP). Before broadband, people connected via dial-up to access providers who often resold that connection to internet service providers. These two work together to get you online. LAC, L to TP, access concentrator. Think of this as a neighborhood gate. It takes your connections and says, hey, I've got someone who wants to talk to the company network securely. It supports L2TP, Layer 2 Tunnel Protocol. It supports Layer 2 Tunnel Protocol, the protocol that builds on the tunnel. Sometimes the LAC feature built right on your device that customer provisions, so your laptop be acting like LAC itself. Okay. NAS, Network Access Server. The NAS is the security guard at the neighborhood gates. It checks your ID, your login credentials, and coordinates. With the LAC, you get your data safely through LNS. LNS is also comes into layer 2 tunnel protocol network server. This is the building receptionist at your company headquarters where your data finally reaches at the office through the tunnel. LNS accepts it and lets it into the corporate network. Corporate VPN gateway. This is the final guardian of the company network. It ensures only secure, trusted tunnels from known users are allowed to reach sensitive data inside. Putting it all together, real life recap. If you the remote employee connect through your ISP from home, your laptop acts like the LAC, forming the forming a tunnel request. The NAS helps initiate it. The tunnel travels through the internet. On the company side, the LNS receives the request, and if you are authorized, the VPN gateway lets you into the office if you were physically there, safe and secure. Okay, original reference scenario, PPP, then LSC, then goes to the L2TP session. L2TP tunnel, we have this in the internet, and then it goes to the LNS, and LNS go to the corporate network. So, what are the full forms of those LSC and LNS? Let's ask it. Form of LNC, LNC, and PPP and PPP. In this scenario, in the above, great question, Pinaki. Let's decode these acronyms from the access VPN solution components with the simple meanings you can connect to. Full forms of real-life anomalies. A device like your home router, ISP, edge equipment that starts the tunnel. The company real-life example. Imagine you are at the airport checking the router. LAC, there are pipeline luggage data that go into the plane. LNS, what is the corporate side device? Usually VPN gateway that receives and finishes a tunnel created by the LAC. Real life example, if a LAC checked by DNS. LNS is the baggage claim area where your luggage finally emerges safely at your destination. Um, this is the access concentrator, and this is the network server. This is the network server, and this is the access concentrator. Okay, LNS is network server and AC is access concentrator and PP is point-to-point control. What it is, the protocol that handles the connection and data transports between your device and the network. Real life example, PPP is like the conveyor belt system that moves your bag from check-in to loading dock. It handles authentication, compression, and error detection while moving the data securely. Memory tape. LAC launches the tunnel, LNS lands it. LNS launches the tunnel, LNS lands it. and PPP keeps the content moving smoothly in between. So it's like PPP. Okay, provider provision deployment. More tunnels and sessions. Multiple sessions may exist within the same tunnel. Multiple tunnels may be established between the same LAC and LNS, or multiple LNS. Okay, PPP frames. So L2TP operation. I think this is operation. Okay. Establish a control connection for a tunnel between LAC and LNS. Establish one or more sessions triggered by the call request. The call connection must be established before a connection requested is generated. Connection request is establishing a tunnel, L2TP header. Let's learn this thing with the layman terms. Treatment is in layman terms. Okay. Layman terms, easy to remember. A VIP tunnel hotel. Wow. It is hotel. You are a remote employee, the guest trying to check in your company secret headquarters, the hotel corporate network using the secure hallway. L2TP tunnel. Here's what happens. Step 1. Build the hallway tunnel control connection. Tunnel control connection. The hotel LAC talks to the headquarters LNC and says, "Hey, I've got someone important coming in. Let's build a secret hallway." This hallway is created control connection. No guest data can pass through it yet. It's just a setup. Open the room sessions, establish one or more sessions. Now the hallway is ready. The concierge creates a session like assigning a room numbers for each VIP task, email, file sharing, video call, each session a room key for a specific service. Without this, no data can be tunneled. The connection must be established before a connection request is generated. Chap style. Confirm the guest identity. Chap style challenge. Before the using the hallway, the security team sends you a challenging question like, "What's the secret paraphrase you and I agreed on this the last year?" You respond using the correct encrypted answer, providing you are not an imposter. This is a challenge handshake authentication protocol, CHAP. Okay, the control connection must be established before the connection request is generated. A session must be established before tunneling PPP frames. This is the CHAP thing. Peer-to-peer authenticated, a shared secret must exist between LAC and LNC. Exchange tunnel IDs. Okay, the exchange tunnel IDs. Local names. Once verified, both ends of the hallway tell each other, "I will call you tunnel #42 and you will be tunnel at 99 on my end." These IDs help keep things organized like a nameplates outside the tunnel doors. Quip memory hook. Build hallway, unlock rooms, answer challenge, exchange IDs. The L2TP layer 2 tunnel protocol uses a chap-like mechanism, challenge handshake authentication protocol. A challenge is proposed to the other people. The correct answer to challenge requires the shared secret cryptographic algorithm is used to create the answer. The tunnel endpoints exchange the local ID attributed to the tunnel. L2TP header, control message, data message. We have this header fields. Okay, then we have this sequence numbers. Let's go. Let's get this one done. Okay. Teach me about in easy layman terms using real life examples. Mamma mia. Absolutely, Blank. Let's turn this LTTP header visually into something super easy to grasp with real-world analogies sharing your favorite characters from a courier delivery service. Imagine sending a secure package between cities. Think of LTTP specialized delivery network that sends kinds of packets. Control message instruction like open a new tunnel or close a session. Data messages, your Excel files or the message wrapped in PPP frames. Now let's break the parts of L2TP header into real life elements. These are the flags LSOTP. This is TL0SOP. T for type 0, it's a packet data message. 1, it's an instruction control message. L length present sequence numbers. S is for sequence numbers. O is for the offset present. Think of these like a check boxes on a form saying I've filtered this section for control message. L equals to 1, S equals to 1, O equals to 0, P is equals to priority. If set this express delivery like a making message urgent. So P represent the urgency. Versions must be always 2, like saying we only accept the delivery slips in format 2.0. There are version controls. Tunnel ID and session ID. Tunnel ID, like assigning a hallway number in a hotel. This is overall connection. Session ID, overall connection of a hallway number. Session ID is each guest, task, or session using the tunnel gets a room number. If it's how you distinguish multiple guests inside the same hallway. Sequencing number NS. NS is equal to sequencing number. This packet 5 of my messages helps spot out the order letters. Wait, where is the 4? Used only to detect issues, not to resend. It detects the issues. NR. This one. Next expected sequence number. The last message I got 7, so expecting from 8 next. It's how control messages acknowledged what they received. Offset. Start reading my actual messages after many bytes. Okay, where is the offset? We have offset size, offset size. Like saying ignore the envelope and header, open the letter starting on line 10. Channels reliable versus unreliable channels. So control channel reliable uses acknowledgement plus retires. Like a courier who confirms yes, I handed it over. Data channel unreliable, no worries. Like dropping regular mail in your mailbox. It gets lost, no one calls you. Real life example summary. You are using a Zoom over VPN from your Florence cafe. Your laptop sends L2TP data packets through the established tunnel. Each video frame is a packet #1, #2, #3 with NS. Server numbers. I think so. Sequence number, yeah, sequence number. The session has session IDs riding through tunnel 88. Occasionally, your laptop sends a control message like keep the tunnel open, that one must be confirmed, and some video frames might get lost, but the control message always arrive in orders thanks to reliable delivery. Want me to? Okay, this is done, this is done, this is done. Sequence number, data connections. Security issues, point-to-point tunneling protocol, PPTP. Okay, kind of easy. So guys, this is my part 1. I will create my part 2 tomorrow. We have covered till offset, and I'm going to start from sequencing number, which is slide number 62 out of 167. See you tomorrow. Good night. Ciao ciao, bye bye, Jai Shri Ram, Jai Shri Radhe Shyam. Let's see.